All right, so we've just been looking at the central limit theorem, and let's just remember that the central limit theorem is a key tool for analyzing X bar and other sample statistics. And one of the conditions for the central limit theorem was that the underlying distribution of X should be normal, or the sample size has to be sufficiently large. So uh, up to this point, I've been fairly vague about, well, how do you know if something is normal? Um, so we're going to look at a couple of ways to decide if a distribution is actually normal or not. Now, the first way is essentially what we've been doing already up to this point, so it's going to seem vague still. Um, now, um, so that would be checking normality using a histogram. All right, so there's actually, so the example we're going to look at here, there's a file, an Excel file with posted on Blackboard called body data, and it has the body weights for 147 randomly selected women. Okay, now I don't have to open that because I've already made the histogram right here. So if we make a histogram for these weights, for these 147 weights, we're going to obtain something like the following. So from this picture, we can get a rough sense if female body weights are approximately normal. So what are we looking at? Well, normal, we're looking at kind of the overall shape of this thing. And the conditions for normality. So normality requires, um, first it should be symmetric. And this thing is roughly symmetric, but certainly not perfectly symmetric. This one is very roughly symmetric. Second thing is it should have one mode, one central peak, unimodal. So this one has, you might say, well, it looks like this one has two peaks, right? If I go like this, it looks like it has two peaks. So this is one of the shortcomings of this approach, is that the shape actually depends on how many classes you have. If I actually reduce the number of classes, I would generally smooth out the distribution, and I might lose that second peak. So here, what should we say? I don't know, more or less, right? And the third condition is that it should have no extreme outliers. And that's certainly true here. We have some larger values, but they're not very far away from the rest. So and the last thing is that it should have the sort of roughly the bell shape, or sometimes you hear the word mound, like a mountain, mound shape. And that roughly has that, this roughly has that property. Okay, so we've already, I've already given you this checklist and already in some cases. The one thing I'm going to add here is, now we can also look at box plots. So a box plot is a good way to check for outliers, right? Especially in Excel. So if we make a box plot for this same data set, 147 women, what you're going to find is a box plot like the following. And it has these dots which represent actual outliers, right? So this the female body heights, is it body weight or body height? It's body weight, I guess. Weight. The female body weights do have a few outliers. Three outliers. Now, the checklist says extreme outliers. Are they extreme outliers? Are they Jeff Bezos level outliers? Are they extreme outliers? Well, that's a bit of a judgment call. They're so remember that the definition of outlier would be it's 1.5 times the interquartile range. So this is interquartile range. If I did one of those, maybe plus a half of those, well, that's this point here now. So this, when you have outliers, the whisker then stops at the last value before the cutoff point. So the cutoff point is potentially a little bit beyond that. Um, and so these points are uh, just somewhat beyond the outlet, somewhat beyond the cutoff point. Something like maybe 50% beyond the cutoff point. So they're we would call those moderate outliers. Okay, now as you can see, this approach is very subjective. It's if something was something really important relied on this decision, you'd be a little worried that it was um, not a very definite decision. So what we can do is attempt to do some more formal quantitative methods for determining if something is normal. Okay, so what we're going to do is I'm going to tell you something here that you're only partially responsible for learning. Um, so I'm going to show you how to check for normality using what's called a normal QQ plot. And what you'll be responsible for doing is if I give you a normal QQ plot, then you can interpret it, but you're not going to be required to make one of those plots. I am going to show you how to make one of those plots because I sense that some students would like to know that, but even though I'm going to show you it, I'm not going to test you on whether you can do that yourself, only whether you can interpret that plot. Okay, so let's give that a try. I think what we're going to do is actually do that in the next video. So I'll see you there.